The cells runs like a column. It's zona fasciculata, and right next to adrenal medulla is zona reticularis. Okay, and then I have the functions here for you. The coloration is a little bit, I'm not going to read it to you guys, but that's pretty much, I mentioned the hormones that comes from those three layers. Glucocorticoids and mineralocorticoids and adrenal sex hormone. These are the adrenal cortex. This would be zona glomerulosa, zona fasciculata, and zona glomerulosa. Okay. Last gland is your pancreas. In the pancreas, you have islets of Langerhans. The first person who discovered them was Dr. Langerhans, and they have two types of, they have more than that, but the only two that you have to know is alpha cells and beta cells. Beta cells are releasing, they do release insulin, and alpha cells release glucagon. Okay, and you know the story behind, and outside of islets of Langerhans is exocrine assadi. These are all called exocrine. These are exocrine glands because in your pancreas, because they release their products into a duct. But this is an endocrine. It releases its hormones, the insulin and glucagon, into blood vessel. I hope I'm making some sense. So now you know the difference between your seeing one. So your pancreas is both endocrine and exocrine gland. Your pituitary gland, the anterior pituitary gland is, and of course posterior pituitary gland, they both are endocrine glands. Okay, so the two hormones, here it is in your diagram. This is a nice, beautiful picture from your textbook. This is your islets of Langerhans, and these are outside of them, which we do have this slide in the lab. This is exocrine assadi. And then insulin and glucagon, they balance glucose level in the blood. Insulin lowers glucose level in the blood, just like calcitonin. You remember calcitonin lowers the calcium level in the blood? So right now for breakfast, you had mashed potato. You have all of these glucose in your blood, and insulin is secreting very hard. Two, and what does insulin do? It facilitates, the function of insulin is to facilitate absorption of glucose into the cells of the body. That's it. If you do not have insulin in the circulation, in the blood, then glucose molecule remain in the blood, and that's dangerous. That's why the person then is diabetic. Okay, there are two ways. Either the cells of the body will not take glucose or will not take insulin. They do not have the receptors for insulin. That's a different type of diabetes. And the other one, there is not enough insulin in the body. So anyhow, I'm not going to get into different types of diabetes. But that's the function of insulin. And when the glucose molecules are stored in your liver as glycogen, or your muscle cells as glycogen, by lunchtime, 11 o'clock, 12 o'clock, before the quiz, or right around your quiz, right? When I say that, you wake up. Oh, quiz, I mean. What? Right around your quiz, what? Right around your quiz time, then glucagon is released. Glucagon is released and goes to liver and muscle cells and breaks down those glycogen. You all know what glycogen is. Glycogen is a chain of sugar molecules. Each one of my sickles is a sugar molecule, and they are attached together. Of course, it can be branched. So, insulin allows the sugar molecule go into the liver and muscle cells, and glucagon, around lunchtime, it breaks them down, and they go into the blood. So the sugar level, this is glucagon. I'm breaking it down with the help of glucagon. So the sugar level in your body, in your blood, it fluctuates, but it has to be within tolerable limits. You remember homeostasis? I talked about that. It has to be within tolerable limits. And that's the end of the material for exam number 1. Is there any question?